Hello everyone, so in this video let us talk about one more problem from LeetCode, medium problem. The problem name is partition list. So let's start. As you can see, you are given the head of a linked list and a value x. As you can see in the input, the linked list and a value x. You have to partition the linked list in such a way that all the nodes less than x comes before nodes greater than or equal to x. So as you can see here that you have to somehow partition this list, and you have to also preserve the original relative order such that you have to partition the list such that all the nodes which are less than x come first, and then all the nodes greater than or equal to x comes list after. So as you can see, the nodes here has the values these things. So what all are the nodes which are less than x? So as you can see, 1, x is 3, so 1 is there, then less than x strictly, so 1, then 2 and 2. So 1, 2 and 2 should come first. The next is greater than equal to x, so greater than equal to x, greater than equal to x, this is greater than, this is greater, like this is greater than equal to 3, which is 3 and 5. So the order should be 1 2 2 4 3 5. So as you can see, that is the overall thing. So it's not much difficult. So what you just have to do here is that you have to form a new linked list. Okay, so you will iterate over this complete linked list, check for every value in the linked list. If it is less than x, then you will add it before. So you have to somehow make two linked lists now. From this original linked list, you will make two linked lists. Okay, now the linked list is that, let's say you will take the linked list as, so this is one left linked list, this is one right linked list. Then you have to just combine those linked lists. So you have to make two linked lists, and every linked list has a left and a right. So what you'll do here is that you will make left head, right head, left tail, right head, and right tail. So these are the two linked lists. So what I'm trying to do here is that you will make two pointers, like as you can see, four pointers, one, two at the heads and two at the tails. Two tails means like the end of the linked list. Okay, so what I'm trying to do here is that if a linked list value, if the value is less than x, then you will add it to the left linked list tail. If it is greater than or equal to x, you will add to the right linked list tail. And then when all of them is done, you will, like you can say, combine these two linked lists by somehow the left linked list end should be equal to the right linked list head, and you will just match both of these linked lists and return the answer. Nothing much complicated here itself. Let's move on to the code part now. If you still have any doubts, you can mention them in the comment box of this particular video. Let's see here what we have done here, that we have created four pointers. As you can see, left head, left tail, right head, right tail. Initialize it with a dummy value because we have to somehow add these nodes inside and make two new partition linked lists. This is the case in which that if the head is null, because always write down if based upon the conditions or the constraints, if it can be 0, it can be 1 as well. If we have 0 nodes or if we have 1 nodes, then we cannot partition it. Like if it doesn't have 0 nodes, we cannot do anything. The answer is that only. If we have 1 node, then we can also don't have to do any shuffling or partition. You just have to return the head, whatever the answer head that you are given as a linked list, return that. If you have two or more linked lists, then only we can reshuffle or do all of this kind of stuff. So that is why we only, if you have two things, then only we are trying to make these four pointers: left head, left tail, right head, right tail. And then what we're trying to do is that we'll keep on iterating over the head, as you can see here. Then what we'll try to do, if its value is less than x, then the left tail next is equal to that head value. You can also make a new node, or you can reuse these nodes, whatever is your requirement. I have you reuse these values. You can also create a new linked list here and then insert the values. So you can also do like this. If you want a new node, so you can make a new list node and the value will be head value. You can also do that as well, whatever suits you best. So that is how you will make the, if it is less than x, you will append that particular node at the left side of the left linked list that you're forming. If it's greater than equal to x, then you will append and do the same thing and add that particular node to the left, to the right of the right linked list that you're forming. As you can see, now you have both of these two partitioned linked lists. Then in the end, so this is how you will move to a new head value. So that is how you will do the complete iteration over the linked list and partition those nodes inside the two left and the right linked lists that you have to form. In the end, what you're trying to do is that after these two linked lists are formed, as you can see, if you form these two linked lists, then what you have to do, you have to make to your right tail next equal to null, so that the linked list will terminate here. then you have to move your left tail, as you can see, left tail next equal to right head next, because first value is dummy value, so they have to make it to the right head next. That is this the first actual value that you are trying to append to the list. That is how you will connect these two linked lists. As you can see, this is the first linked list, this is the second linked list, the first is the dummy in both of these linked lists. So that is why you have to somehow append both of these linked lists like this. So that is how you will append, and in the end you will return the left head next, because the first value of the left head is a dummy value, so you will return a left head next value. And that is how you have combined these two linked lists. As you can see, these two combined linked lists, and return the combined linked list as the answer that has like satisfied this condition. That is also, as you can see, just requires, as you can see, we're not making any new nodes, so no space complexity required. We are just using constant pointers, and the overall time complexity is O of n, because we are just iterating over the complete linked list once and doing these things, and in the end we're just like remapping these pointers, so nothing much time complexity here, only the time complexity is O of n used by this file. That's the complete thing and the complete time complexity of this particular code and problem. If you still have any doubts, you can mention in the comment box of this particular video. I will see you in the next one. Thank you, coding, and bye.